Sorry, sir. Can you hear me? Your audio is weird. It sounds very weird.
Okay, is that better?
Yep, it's much better now. Thanks.
Sorry about that. I have a weird thing with my microphone where sometimes when I turn it on, it must be an initialization issue, and I sound like a chipmunk. Apparently, because I don't hear myself through the microphone. I'm not sure what it sounds like, but I've been told it doesn't sound very good. The only way I can fix it is switch to a different microphone and then back again. So, thank you, Ren, for letting me know. So everyone, about 4 or 5 students completed the quiz. I'll put up a summary like I did last week, but if I sort them, it looks like there is probably quite a few more students this week, got 2.5 out of 2.5 than last week. And if I sort the total over the 2 weeks, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, probably about 15 students so far who have got full marks in both of the quizzes. So it is possible. And it looks like the average this time might be a little bit better than the previous time, which is good. This week, there was also a question in the chat while people were finishing off the quiz about the notes. I will endeavour in future weeks to make sure they're up much earlier, even if often I'm still working on them, just because I've got time to kind of keep tweaking them. But even if I've only got a draft version, I'll put a draft version up a few days ahead of time, at least, so that you can kind of have a look at them. So this week, I want to focus on IT life cycles and the role those life cycles play in ensuring kind of project success. And by project success, that kind of feeds into business value, etc. So in some respects, this is key to your project, because a large part of your project is about exploring the value that can be added to a business through a particular technology. So I'll have a look at how that works. The second half of tonight, as usual, will be a guest presentation. This week it'll be from one of our tutors who knows this area inside out, Dr. Andrea Stern. So she's going to share some of her expertise and wisdom with us, and try and take some of the broader theory that I talk about and explore kind of what that means in a more detailed, practical way. And at the end, there's a few bits of admin I'll go through at the end as well. So this week, there's a great quote by someone called Milt Bryce. If you don't know who he is, you should be able to look him up. But he kind of talked about the fact that if we lived in a perfect world, then things would work cleanly, projects would be a success, we'd all be happy, etc. But we don't live in a perfect world. We live in one that is imperfect. People make mistakes. We do things incorrectly. We mismeasure things. It's a whole range of imperfections. And that leads to kind of challenges. And so a lot of our practice in IT, as in any area, is about managing those imperfections too, so that they don't create enormous problems for us. If I look at project management versus the concept of technology life cycles, a lot of today I want to talk about broader technology life cycles. People often misconstrue that as kind of relating to projects and therefore project management. All projects have a beginning and an end. They obviously start somewhere and they finish somewhere. All projects are unique. Every project is different in some way, and all projects utilize resources and have deliverables, etc. So they're kind of fairly obvious things. Technology life cycles kind of takes that further. So one of the challenges with implementing the technology in organizations is understanding where that beginning is, and probably even more so where and so in technology just about that. Sorry, just mute the person who's talking, who've got their microphone off. So all projects start somewhere, end somewhere. Life cycles often goes beyond that and says, well, where do they begin? Where should they end? How do we manage that? I mentioned all projects are unique, but we can take learnings from other projects, and in particular, what that tells us about how we might manage this one. And the kind of key interesting thing is that whilst all projects utilise resources, have deliverables, in that sense, we can usually sort of say, for this project, here is what we're trying to achieve. One of the interesting characteristics of technology, and particularly IT, is that it changes the environment in which you put them. Let me sidetrack for a moment. I had a colleague who used to tell me that the IT profession was the profession that it was most similar to. You'd often think, oh, is it kind of a bit like computer engineering, electrical engineering, because it's got, has overlaps in terms of the technology? Is it more like, maybe psychology even, etc.? A colleague who used to argue that computing, the computing profession was most like civil engineering. And I originally thought, civil engineering? That seems quite different from computing. And when they explained it, the reason they said it was most like it is because civil engineering projects change the environment in which you put them. So in other words, you might say, oh, we have traffic problems through this part of the city. And so we've got this much traffic, it's a problem. If we build a new road that can cope with that amount of traffic, we should solve the problem. So you build the road, and all of a sudden, because there's a road there, it changes people's behaviour. And so suddenly that road isn't enough. Or it means that suddenly people sort of think, oh, we can build more houses over here because the traffic's now better. So implementing one solution triggers a change in a whole lot of other areas, often meaning that the solution that you thought was the necessary one no longer is, because the problem itself has changed. And IT does that. It causes changes to the domain in which it exists. And so when you think you've found a solution and then you implement it, that solution is no longer the right one because you changed the problem. And a key part of analysing all of that is looking at the value that should be provided. An outcome of all of this, and why this kind of presents a real challenge for people working in the IT industry, is understanding what the scope of a project is. What the scope of, not a project, what the scope of the adoption of a particular technology is. It's not just that project, because you implement the project and then things keep changing. It's understanding how that kind of works in the environment in which you're putting it, and how it will reshape that environment, and where that goes from there. So, I'm not going to talk at all or much about project management. Project management is often seen as the solution to this. We'll manage our project. You'll talk a lot about project management in detail in the IT project management course that many of you will be doing or are doing, or is it part of your program? I guess what I wanted to point out is that there's a whole raft of different project management techniques and methodologies that have been adopted in all sorts of ways. Everything from kind of conventional waterfall models to Scrum or Agile techniques through to DevOps, etc. All of those are invariably developed to solve particular issues within the development life cycle, or the development phases of the life cycle. They often work in that context, but often once you look at the broader elements of the life cycle of a project, you discover some of the limitations of them, and maybe even more so for every different type of project and every sort of problem that emerges, people come up with a different variant of project management options, and you end up with, I thought I had another diagram there, but I must have removed it. But I'll find the one that I had and make it available to, or maybe it's later in the slides. But anyway, so you get this kind of concept of project management and methodologies. Compare that to the overall product life cycle, so that you're not just looking at, oh, we need a CRM system, so we'll have a project that rolls it out and designs how it's going to fit into our organisation, and then we roll it out and then we stop. So the full product life cycle goes from the conception of a project. That's largely what you're doing at the moment with your projects. You're saying, oh, hang on, there's this technology that could improve the way our business works in some way. So you're kind of at that conception initiation stage at the moment. Your discussions with your tutors about would this be a useful technology is largely about that aspect. Then you go through this phase of definition and planning. You implement it. You launch the project. You implement it. You go into an execution phase. And at some point, the system that you're or the technology you're adopting or the system you're implementing starts being used. And then you'll go into an operational phase where you are monitoring its performance, you're controlling the way it's being used, etc. And at some point, you'll wind it up and you'll get essentially what I've said there is project closing, but is more about technology retirement or product retirement, where you gradually remove it. And where that exists is really challenging. There are technologies that were put in place that were supposed to be used for 2 years and ended up being used for 30 years. And that's not just in IT, it's in any industry. Technology ends up being used for much longer than we often believe it will be. So if I compare that product or project phase versus a product life cycle, the key difference is really about that whole life cycle. It's about understanding end to end how the technology is going to be used. Let me talk a little bit about IT projects and failures. There's a list there of really good project failures. There's a bad phrase. Really good examples of projects that have failed. And I'd encourage you to go and Google those. If you look up online, you'll find hundreds and hundreds of great case studies of IT project failures. The ones I've listed there are ones where there's a reasonable amount of information. They kind of and they've been dissected well to identify where they kind of went wrong. I'll talk about one of those in a moment, but if you wanted to pick another one other than the one I'm going to talk about as a good example, go and look up information on the Queensland Health Payroll System and explore why that failed. If I was doing this in a normal face-to-face classroom, I would post a message, I would ask you all to let me know let me try this. Can I, just to see whether this works? I've got a question there. Why did those projects fail? Can I ask anyone to see, all of you, to see whether or not you can give me one word that describes why you think those, or one or two words, bad management, that's 2 words, and that's good. Why those projects failed. Cost, cost is a measure of the project. You can get projects that are incredibly expensive, but they're still successful. So the question is, why might the cost or time have gone out? What was the underlying root cause of that? What caused a project to become over budget? Those things like being over budget or costing too much are measures of the failure. What's the cause of the failure? I've got someone put in scope creep. Absolutely. When that's often you sort of didn't scope it out correctly at the beginning, and then you keep adding more and more things as you go along, and it keeps changing so that you're never quite hitting the target. Unrealistic goals, absolutely. You can kind of get a clear view of it, and requirements unclear, requirements nuclear. I suspect that's supposed to be requirements unclear, not nuclear. Absolutely. Bad management, poor risk management. There's a lot of kind of versions of management, both and risk management going in there. Manager, same sort of thing. Miscommunication is kind of a form of management. So absolutely. But look behind those. Why was it poorly managed? Why were the requirements not clear? Why was there scope creep? In other words, if you keep kind of drilling back, what kind of underpins that? So that actually worked better than I thought it might. So thank you for all of those who posted comments. Might try and do that again more often. So let me look at this case study, the one that I did want to look at, the New Zealand Police INSIS project. INSIS stands for the Integrated National Crime Investigation System. And there's a reference there to an article that kind of analyses this. This one's from back in the 1990s, which sounds a long time ago, but the lessons from this are still relevant, and the underlying causes of this project to be not as good as it should have been still exist today. We're still making the same mistakes. So this project kind of started in 1993, where the New Zealand Police Force said, we want to manage our crime data much more effectively. They had an initial estimate of about $30 million spread over 3 phases of development. And they sort of said, well, the annual cost of crime to the nation is about a little under $5 billion per year. And if we can get a better information system that lets us manage that, predict where things are going to go wrong, have data that tells us where we should be investing our expenditure in terms of resources and police and whatever, then potentially we can get huge savings. And the estimate for the project was benefits of about $5 billion over the lifetime of the project. And it was originally going to cost them $30 million. So that sounds like a fantastic deal. Spend $30 million and get $5 billion back over the life of the project. So it was kind of they thought, this is fairly obvious. Over the next couple of years, they kind of explored it a bit more. They elaborated on it. They did a bit more detailed analysis. In 1995, there was a new set of requirements that were a bit broader, but still not too bad. By 1996, the environment was changing. The operating system that it was going to operate on evolved. There were changing network, some of the underlying technology that it was going to use. So the network protocols changed from being token ring to being TCP/IP based. So it was, there was parallel evolution of both the business domain, the requirements, and the technology domain whilst the project was underway. And that happens. One of the consequences of any significantly large project is that it takes a few years. And over that time period, things will change. And so the result was that by 1997, the project was at least a year behind. The project manager was getting frustrated at how it was being managed, the fact that things were changing. So he resigned, and it just got kind of messier and messier. By 1998, they had revised the estimate for the project to be $118 million, 4 times the original cost. So the cost was going up and up and up, and they still weren't making good progress. By 1999, 6 years after the project was first conceived, the first phase out of the 3 phases was complete, and the cost estimate had now gone up to $130 million, and problems were still appearing. In 1999, the hardware supplier pulled out. They were just getting too frustrated with the project and why it was going around and why it wasn't making a better project, and they just said, we're pulling out of this. Following year, they just sort of said, the New Zealand police department pulled the plug on the project. They just said, we can't, this isn't working, we can't resolve it. We can see that we're not going to get an outcome within the kind of cost envelope that is feasible, and they cancelled the project. They just pulled the plug on it entirely at a cost of well over $100 million spent, only the first phase complete. And so there's kind of a question about why that was the case. What actually triggered that? What went wrong? It was a lot of those things everyone talked about. It was changing technology and an inability to get the architecture right, given the technology that was available, particularly given how long it was taking. It was changing requirements, but ultimately it was about problems with understanding how that life cycle or those elements should be managed. So let me talk a bit more broadly. Earlier on I gave a list of 7 or 8 other projects that would be good to look at, and as I mentioned, any of those would be good to look at. But if you're going to look at one, go and Google Queensland Health HR system or payroll system, and look for information on that. And it will, there are some great articles about where that went wrong and why. There's a great statistic, and depending upon where you look, the numbers vary, but they don't vary much. Typically, there's data that says close to 30% of software projects fail outright and are cancelled. 30%, almost 1 in 3 large software projects never see, get to completion. They're cancelled before they're even completed. Another 40% have major problems, significant cost overruns, significant time blowouts, functionality that doesn't achieve what was intended, etc. And so in other words, somewhere around 70% of software projects can be considered to be a failure of one form or another. That's disastrous. If you thought about that kind of problem occurring in any other development industry, it just wouldn't be tolerated. If a bridge, I was talking before about civil engineering, if a bridge falls down, then they go and work out why. It's analysed, a report's written, often there's a public inquiry, and they make sure that changes are put in place to the way those projects are developed, managed, etc., so that the same problem won't occur again. You might get a different problem that then leads to the same process, but there is this incremental improvement in the standards around how these projects are rolled out. Software, we just keep making the same mistakes time after time after time after time. Failures are ignored or covered up or rationalized, and we just keep making the same problems. And so there's this key question of why is that happening? I talked before about different process models, waterfall, agile, DevOps, DevOps with iterations. They're all intended to deal with elements of these problems. And waterfall was developed 50 plus years ago as a methodology or an approach to developing software. They sort of said, if we're going to develop software, we need to get our requirements clear. And so we'll do requirements up, and design at the beginning. And we'll get that right first, rather than just building it. We need to have a clear specification of what we're building. So we'll build it, then we'll specify it, then we'll build it, then we'll deploy it. That was kind of the rationale behind waterfall. Then they sort of say, but hang on, requirements keep changing. And so if we try to specify it up front, right at the beginning, we'll probably get it wrong. And so we'll adopt an agile approach. We'll do a bit of specification, a bit of design, get some feedback, feed that into the next one. And so we get this nice kind of iterative process. But then that means that you're still building it before you get to deploy it. So we'll integrate the development and the operations and create a DevOps process. each one of these is supposed to be trying to improve what we're doing, but we still get project failures. And I mentioned, now I've got the slide that I forgot about before. This kind of shows that huge range of different processes that have been developed, methodologies that have been developed to try to deal with these sorts of problems, to try to understand where things are going wrong and adapt the process. The problem is, it's not just the process itself, it's the context in which that process sits. It's the fact that we have been treating IT and implementing IT in an organisation as a project, and therefore subject to project management, rather than exploring the entire life cycle of it and integrating it into the environment. And so, we end up still with project management challenges at each stage of the process. Every bit of it, we get kind of problems in each of those phases, because we're not taking into account that broader life cycle context in which the system exists. We're not trying to understand the business value that's brought to this, the way in which the systems will integrate into the business environment. I'm kind of spiraling around this a little bit into, and I keep coming back to this concept of project failure. I asked you earlier why projects fail, and you gave me a whole lot of these things. People talked about poor communication, or poor management, poor resource planning, unrealistic schedules, project requirements, either getting them wrong or having them keep changing on us. I don't think I saw in the chat window lack of stakeholder support, but often projects are viewed as failing because there's not kind of a stakeholder commitment, a true stakeholder commitment to them. Undefined project success criteria, that's kind of saying, well, we don't really know what we want out of the project, etc. No risk planning. I think someone did talk about risk management or mention risk management. So a whole lot of reasons. If you look at if I take the top 4 of those from that graph, or that chart rather, poor communications, insufficient resource planning, unrealistic schedules, and incomplete project requirements. They were the top 4, and most of the others kind of have similar elements to it. Have a look at those. Have a look at the words that I've put in bold, and think about those. So if we've got poor communication in a project, communication about what? In other words, if a project fails because of poor communication, what is it that we're not communicating? Insufficient resource planning. What's the planning supposed to be for? Planning for what? If we have incomplete project requirements, requirements for what? When you were putting that list into the chat for me, I commented on working through into the kind of underlying root cause. So look at that bottom one, incomplete project requirements. That's kind of saying, well, yes, we've got a project, our project is failing because we didn't properly document the requirements. So as we develop it, we're realizing we're developing the wrong thing or an incomplete thing because we didn't document the requirements properly. But I then said to you before, drill behind that. Why do we have incomplete project requirements? What's the cause of that? So let me kind of give you a little bit of a hint. This diagram comes from the 1970s, and some of you will have seen it. If you haven't, then you'll be able to find it online. And there's subsequently lots of variations of this. I think this might have been the original version. If you look online, you'll find ones that now have 10 different trees or 20 different trees, and the phrases are slightly different or whatever. But the concepts are all much the same. And as I said, this dates back, from the 1970s. So, least 40, maybe 50 years ago. And it kind of says a lot about why, projects fail. And it starts to get towards that root cause a little bit. You look at these and you kind of laugh a little bit because they are kind of funny. In each case, what is being implemented is different from what might have been desired. In other words, marketing sort of thought, we want it to look fancy, so we'll kind of make it, add additional things on. Sales sort of says, we can make more money from the maintenance, so if we design it this way, it'll work better. Engineering sort of said, our specification said, there needs to be 2 ropes attached to a seat, and those ropes are attached to the tree. And so you design it that way because you didn't understand as a designer, you didn't understand how it's going to be used. You just knew what your specification said. If you manufactured it, again, the same sort of problem. You don't have an understanding, the manufacturer doesn't have an understanding of its use. And so it's correct in that, it's got a seat with 2 ropes attached to the tree, but there's a fundamental problem in this case, obviously, that it won't swing. The 5th one, as the field service installed it, in this case, you installed it, realised that it's not going to swing, and so you modify the system that it was put into so that it can kind of work. And in the reality, is all the customer wanted was something they can sit in and swing on a tree from. And somewhere along the line, that often gets lost. There's one wrinkle in this that's probably worth pointing out. The quote at the bottom of that last frame says what the customer wanted. The question is whether or not the customer knows what they want and what gives value to the customer. It may be that the customer said, I want something that's much fancier, whereas what we've actually added value to them was what's shown there. So there's kind of a slight wrinkle in that as well. The kind of point of this is so much of understanding IT and IT implementations is deeply about what adds value. If you look at the first five frames there, none of those add value. They're not really what's needed. This end one is the thing that actually would add value to the customer. Lets them do what they want without any unnecessary elements that just get in the way. And so if I go back to here, poor communication about what? About the client's customers' needs, working with them to understand what's of value to them, and when and how that value might be rolled out, planning for what, planning for the visibility of that value, etc. So let me take a sidestep for a moment and talk about the triple constraint, or sometimes called the iron triangle. So you'll see in this week's terms the phrase iron triangle. Essentially, that's just another term for the triple constraint. And essentially what that does is to say we have kind of 3 real constraints. The scope of the project, the bigger the scope, the more challenging it's going to be. Time, the sooner you want it, the more challenging it's going to be. And cost, the less you want it for, the more challenging it's going to be. And it's called a triple constraint because those 3 things are kind of interdependent. If I say I've got this scope and I want it this fast, then the 3rd one is kind of derived from that. You'll come back and say, well, you can get that scope and you can get it quickly, but it's going to cost you a lot. Or you might say, I've only got this amount of time and this budget, and you'll be able to go back and say, well, that means we have to cut your scope back. So those three things kind of are independent. You often hear people talk about, those three things, pick two, and I'll tell you what the third one needs to be. And the project manager is essentially bound by that. The kind of question is how you then resolve that within the context of the overall project. One of the things that's worth thinking about is for your project, with your technology and your company, where do you sit in that those three elements? What one is going to dominate your project? Which one of those is kind of crucial to you? So think about that in the context of your project. There's a couple of quick other things that I want to talk about, some more slides. That I don't want to spend too much time on these because they're a little bit kind of lateral, but these are more just to kind of get you thinking about some other related elements around project life cycles. So in terms of managing a project, one of the most common tools is a work breakdown structure that sort of says, what are the different tasks? Then you go on and say, what's the amount of effort that's going to be required for those? What are the dependencies between those activities? And then, how do you turn that into a project schedule? So let me talk about each of these kind of in turn. So work breakdown structure, it is a useful tool. It gives you a focus on kind of the deliverables within a project and how they kind of group together to organise the overall scope. An interesting challenge is how you kind of derive the elements of that. So let me give, I thought I had another slide there, but I must have, again, moved it. You kind of want to think about how you slice the project up to make it kind of manageable. There's a kind of an interesting question around granularity and how much detail is sufficient. So how kind of finely do you divide up a project in order to manage it? Does that kind of diagram there have enough detail? Source tools, build API, test API. You could argue, well, it probably doesn't because the build is kind of a long phase with no detail, and so it's not really particularly clear. There's also a question around how you divide things up. So if I was not an IT example, which is something that you should be familiar with. If I was building a house, then I can kind of break that down into site work, preparing the land that I'm going to be building my house on, clearing it and excavating and putting in the utilities underground and laying the foundations and doing landscaping. Then there are kind of the architectural elements, essentially building the house. And then there are kind of the electrical mechanical things, wiring in, doing all the plumbing, kind of adding on in the other bits. So I could break it down that way, or I could break it down that way. I change in particular, I'm changing the latter two, the architectural structural elements and the electrical mechanical elements into things inside and things outside. And in terms of breaking the work down, that which of those makes more sense? Which of those is going to be more helpful to me in how I manage my project? And that will often be driven by the types of roles that are being carried out, by the sequencing that occurs, etc. So if you think about that kind of issue about how you divide it up in terms of an IT project, one of the key kind of factors in any IT project is the way in which you construct a work breakdown, identify the elements that make up your overall project, not just in the development phase, but throughout the whole life cycle, will change the way in which you conceive of the way in which the technology is being used and will be managed. So it's a kind of a critical issue. Both are correct, but which one's better and why? One final comment. The projects that fail, I gave that example of the New Zealand crime information system. That went on for, I think it was 8 years before they cancelled it. And by then they'd spent a lot of money. It's obviously, it should be really clearly obvious that it costs a lot more to to cancel a project at the end of the project than to cancel it at the start. And so if you're going to have a project that isn't going to fail, that is going to fail or isn't needed for whatever reason, then you want to know that at the beginning. The reason why this is important is to think about this in the context of the project you're doing in this subject. You're picking a company. I gave an example earlier in the semester about a supermarket deciding to use positioning systems, sort of Bluetooth localization. And so you might get a supermarket, Colesworth, who says, almost everyone who comes into our shop has a mobile phone on them. Most of those phones will have Bluetooth turned on. There is now technology that allows you to ping Bluetooth, and even if you can't connect with the phone, you can detect there is a Bluetooth device there, and you can then track that as it moves around the store. So the supermarket says, oh, actually, that means we can see where people are going in the store. Using Bluetooth, we can implement it. We can see where they're going, how long they spend in each place, how often they backtrack, and then we can analyze that data and change where we put certain groceries to increase the likelihood that people will spend more whilst they're here. So there's kind of a rationale. There might be a whole lot of reasons why that's a really good idea and could result in a useful, valuable project that makes a lot of money for the supermarket or the supermarket chain. There could be a whole lot of reasons why that would be a disaster. It may be a disaster because customers would be very upset that they're being tracked, and so you'd lose business. Or it may not. It could be a disaster because the technology is changing quickly, and it may be that, I suspect it won't be, but it might be that most people's phones won't have Bluetooth on them in 5 years' time or 3 years' time, and so you just spend 2 years building a project that's not going to work. It may be that does work, but there's cheaper, better, more accurate ways to do it. Maybe you can put cameras up and just do face tracking and use cameras to track where someone is. So there can be a whole lot of reasons why the project might work, and there can be a whole lot of reasons why it might not. But if we discover that it isn't going to be useful and it isn't going to add value, you want to know that sooner rather than later. So the purpose of your project at the moment is to say, we've got a company that we understand. They're thinking about using a particular new tool, technology, capability, whatever. We've got a company that doesn't use CRM systems, and they said, we're going to implement a CRM system. Is that useful to them, and why? And so the objective of your project is really to determine that for that technology and to explain to the board of the company your recommendations about that technology. And the recommendation might be to say, when we really explored this, we discovered that for these reasons, it's not a good idea. It won't work for us. Or your recommendation might be, this is a fantastic idea and will be really worthwhile. So that's kind of the point of this. And to know that now, rather than 2 years and $100 million of project spend later. So they're the things that I want to talk about today. We'll have a break for 10 minutes for you to stretch your legs and get a drink, and so that I can check the chat window and make sure there weren't any questions that I want to follow up on briefly. And then after the break, Andrea will come and talk to all of you and give you the benefit of her fantastic insights. So we'll have a break, and it's now 5 to 8 Sydney time, so we'll start back again at 8:05. So thank you, and we'll be back shortly. Okay, everyone. I think I should be able to. I'm just checking to see if Andrea is online. She should be. I just had a message from her a moment ago. So let me stop cancelling, stop sharing my screen so that Andrea can share hers. Andrea, are you there? Yes.
I'm here. I am, okay, using the wrong camera. Just a minute. I'm not in my usual place. I am...
No, you're in ABS apparently.
I'm in ABS and using different equipment.
That's brave.
Oh, me.
There we go. Now you've got the right camera. Welcome, Andrea.
Hello, David.
So, I don't think you need an introduction. Everyone knows you. Normally I would introduce our guest presenter.
You don't need to. They do know me. I think everyone knows me. The people in my tutorials know me.
So, shall I just hand over to you and let you
Yes.
share the screen and do what you need to do?
Tairi is just getting the slides onto week 3. But I can run them from here, can't I? Yeah, I'll run them from here then. Sorry, I'm a bit slow with them. It's very... Sorry. I'm having a bit of a problem with my browser at the moment. Here we go. I'm not sharing my screen yet.
While you're doing that, I noticed Pooja Mahajan asked a question in the chat about what's the criteria to achieve a HD in the subject, and I somewhat glibly sort of said, 85 out of 100 is the criteria, and I always intended to kind of follow up. But essentially, an 85 is a high distinction. A high distinction means that you've demonstrated kind of outstanding mastery. So at a really basic level, a pass means you've kind of demonstrated enough understanding for us to say, yes, you can pass the subject. A credit means you've kind of gone beyond just that very minimum level. So a 50 pass is kind of minimum that's needed to pass. A credit means that you've shown a more detailed level of understanding. A distinction essentially means that, really excellent, that you've got great mastery of it, and a high distinction is kind of outstanding. And so the kind of level of the criteria is basically that you've shown deep insight into the materials, both in terms of the breadth that you've got kind of and depth. So you show that you are able to take the concepts, apply them in new domains, almost at that level where you could teach someone else them, because you've shown real kind of deep insight. For those of you who don't know what it is, I'll post something on Ed later on about Bloom's taxonomy. I'm not a huge fan of it, but there are some interesting bits in there that kind of talk about different levels of understanding. And you go from rote memorization of concepts through to the ability to apply it, to the ability to understand it, to apply it in different contexts, to kind of extend it. I'll give a little bit of an explanation about that, because that's kind of a good way to articulate what the difference between kind of pass, credit, distinction, high distinction is. So I'll talk about that on Ed. So look for a posting there that kind of gives a bit more clarity to it. Andrea, over to you.
Yes, okay. Sorry, I'm working from a tiny little Surface Go, and I usually have two screens. Can you hear me okay? Because I'm just using the inbuilt mic and camera.
I can hear you very well.
Good. Can you see me? I can't quite see myself, but I don't need to see myself. Okay, so today I'm going to put what David has said into both a slightly broader organizational context and a practical context. And I'm also going to give you lots of clues for your projects, because I'm going to talk about, go through an example of that, of how you might do that, using the link that you gave us, David, to the Bluetooth location tracker. Already gave them. And then I'm just going to talk about some spectacular failures and what that looks like. Two different perspectives. One is, what does that look like from the high level of an organization? What happens up there? And also, what does it look like from the inside? So I'm going to give you tell you some war stories from the war rooms of large-scale disasters. So we start with, wait a second. How do I, sorry, I have my assistant here. How do I move that out of my slides so I can read them? Not that, this. Oh, okay. How do I move it down the side?
Hide, okay.
Hide. Thank you. Okay, never mind. We'll just I can look at the board. Okay, sorry about that. Yeah, maybe it was a mistake to stay here instead of going home. Okay, so I'm going to look at what is sometimes called the life cycle of IT in organizations. It's a pretty broad term. I start with family project, because a family is an organization like any other. It has yes, people who are bosses and people who are not bosses, and lots of projects. Then I'll go on to talk about what a whole of life cycle view of organizational IT looks like and where projects fit within that. An example of a team project, your team project organization, which is a supermarket, what David was talking about, and the IT life cycle within that organization, and some project failures looked at through a life cycle lens. So let's start with the family project. Here it is. The background for the project is that there's a family of two adults who are joint CEOs, otherwise known as mum and dad, and two young children who are consumers, let's say. And they're all living in Australia, which is an important part of this. The project requirements were to create some sort of household security system, which is pretty ordinary. The project tasks were to research security options, to select the most cost-effective of those options, and to acquire a security device. And the project completion was to install and activate that device. So after some deliberation and quite a lot of money, this was the result. That was the security device. Whose name is Pippi. Some of you have met Pippi. Now, these were the initial specifications for this security device. They were that it would become, of course, large. The security device is now 46 kilos and is responsible for the broken wrist that I turned up with at the beginning of the semester in the bright red cast. There are the rest of the specifications of it here, weight 42 to 53. etc.
Someone wants to know how you recharge it. Somebody asked, how do you recharge it?
How do I recharge the security device? A certain amount of food recharges it, but an enormous amount of love recharges it, which it gives back in return. She, gives back in return. What was the question before that? Oh, it's Bernese mountain dog. So it's a little bit smaller than a Saint Bernard.
Is it compatible with the existing leash?
With my existing leash. Is it compatible with your existing leash? Well, I tell you, the leash I was using when I got pulled over by this beautiful dog and broke my wrest didn't work. So we're going to reconsider. I do need an upgrade. Yes. Yes. So that was the result of our project. We specified what we wanted. We acquired it at great expense, I must say. It would have been much cheaper to put in an electronic security system, but not nearly as cuddly as this one. And that's where you think, oh, good, we've got our security system, we've got our puppy, isn't this fun? But what happens next? So the project's finished and it's been installed. What happens next? There is routine maintenance, feeding, exercising, and training. Capacity planning. How do we adapt the housing for it? How do we take it around with us when the kids go to school? Pippi wants to come along, so that means a car that's big enough not just for kids but also for Pippi as well. 46-kilo Pippi. Change management. Increase in housing and transport capacity as I grow bigger and bigger, and that has to be dealt with through a change management process. We need a new car. What do we need it for? We need it to fit Pippi in. What can we afford? How big does it need to be, etc. Lots of decisions and lots of money. And then, you notice I said it was important that this family was fitting in. The family, of course, is my daughter and her husband and two of my granddaughters. And the family got a job in the Netherlands, in Europe. And so they had to migrate there for a number of years. And my daughter said, I'll go there without the children, but I won't go there without the dog. The dog has to come. So the dog had to come. Now, the plane ticket for the dog cost more than a first-class air ticket for a human being. Nevertheless, the dog had to go. So these are all the costs of running the security device. Contingency management. How do we manage risk? Okay, so we get some vaccinations. Disaster recovery. Now, this dog, when it's standing up, I don't have a photo of it standing up, but it has you can see my hands. It has a long tail which moves in a circular motion quite fast. So it's going like this. So if you have a lot of people around, we're having a birthday party, there are drinks and food on the coffee table, off they go. We also have small twins in the family, and they sometimes would also get knocked over. Incident management. Pippi developed a limp, so we had to see what the limp was about. So we investigated the incident of Pippi limping, and we couldn't fix it. So we had to go into a problem management process and do root cause analysis, discovering that it was arthritis. Then we had to restore the security device to its operating state and replace the hip. Again, went through a change management process. Which vet shall we use? Shall we definitely do this or just leave her being arthritic, etc. And of course, there were substantial bills for that, etc. Now, what the etc. includes is my recent $300 MRI, the cost of my cast, etc. So there are many things that will still happen. So you've got a puppy and I'm so cute, but what happens next? This is the whole of life cycle view of the outcome of a project. And interestingly, the cost of maintaining Pippi to meet requirements outweighs the cost of acquiring me. And that is true for, very much true for IT services, which is the outcome of a project. So the initial development cost is much less than the cost of running the result of that project for over its lifetime, running, maintaining, changing, and doing all of these things that I've just talked about. And there she is now, as tall as me. Actually, she wasn't quite fully grown then. I think she can now put her paws on my shoulders. So let's take that, a whole of life, let's transfer that to looking at an organization. A whole of life cycle view of organizational IT. What is a project? You've already talked about that, a temporary endeavour undertaken to create a unique result, a set of functions, a Pippi, managed by project management techniques. Example, the development of the Sydney student application, which I expect you all use. What is the result of a project being completed? Is it just deployed and it sits there and it works and you press a few buttons every now and again? No. As we can see, the result of a project being completed is the continuous delivery of those functions to users from the IT infrastructure, which I will also refer to as a technology stack, owned or controlled by the university. And how is this, if we're spending something like 80% of the IT budget on this continuous delivery over time, how do we manage it? We have processes for managing it, such as IT service management processes and DevOps processes, which David talked about earlier. And the management of that continuous delivery over time is done always in the context of the organization's strategies for creating value. It is also subject to continuous improvement processes. So in your project, you're going to be looking at how your technology will increase or support value generation of your organization. That alignment with organizational value is continued, and managing to keep the delivery of that technology, that app, in line with the organization's value happens all the way through. And as the organization changes and the way in which it perceives where it can get its value from or how it can increase its value changes, that will cause changes in the app as it is running. And that will then go through change management. There will be projects for doing new things. If there is a continuous improvement that needs to be done to it, that will be run through projects. So projects are all happen all through the whole of the life cycle of organizational IT, not just for the creation of a particular IT artifact. Included in the IT lifecycle is that everything related to is everything that's related to the use of IT that is used to deliver organizational value. So that includes, I don't think I've said it here, but I'll say it verbally, that includes people, processes, contracts, policies, procedures. They are all considered part of the assets of IT if they're related to IT. What happens before and after IT projects in the IT life cycle? Before project initiation, We we do strategic planning to determine what's going to be of value to the organisation, what the costs will be and what the risks will be, and balancing value, costs and risks, okay, or benefit, cost and risks. During the project, requirements are set, the app is designed, built, tested and integrated into the live environment. After the project completion, the results of that project operate in the live environment, in which processes manage incidents and problems, report status and projections, the continuity, risk, and manage service levels. So there's a lot going on in that. And then in all stages, continuous feedback and improvement. And here, this is a diagram of the stages of the IT life cycle. And the ones that I've highlighted in red are the ones that are typically associated with projects and project management. So you can see how they're included in the overall IT life cycle. So starting with, as I said before, planning questions about, these stages are actually taken from ITSM frameworks, but they also relate to DevOps. They're similar for DevOps. So strategy, planning questions about organizational goals, what's the business value, etc., things I've mentioned. Design build are the functional requirements. That what will the application do, and non-functional requirements, what capacity do we need, what kind of availability has to be supported, how do we achieve continuity of service, and how do we arrange for security. Now, all of those things, when we're taking a whole of life view, don't relate only to an app that is built inside an organization. It's all relate to anything that might be outsourced, which could be apps, it could be servers, you might be using AWS. Everything at this stage has to be included in this, in the design build. Once that's completed, release into the live environment, where we have processes of change management, asset and configuration management, meaning you have to know where absolutely every item that is involved in running the result of this project is, where it is, and what its status is. Is it operational, non-operational? Knowledge management, testing and validation, release and deployment. So asset and configuration management doesn't normally belong in, as I understand, in my memory, doesn't normally belong in project management. It's often quite separate, but in this model, it's included in the transition into the live environment. So you can't put something into the live environment unless everything that is related to it is recorded in a central database. Ongoing operation manages events, which is something that happens maybe typically to do with a piece of software or hardware failing. Incident management, something that a user reports has gone wrong. I can't get into Canvas, as we couldn't about half an hour ago. I am not just talking to myself. Chadri is right next to me, helping me. And in the operational stage, everything is monitored and controlled. Everything that's happening in every configuration item, every bit of software, every bit of hardware, everything that's outsourced, everything that's insourced, etc. And that's becoming increasingly a highly automated area. And that's very important for DevOps. And then finally, continuous improvement, the main concerns of which are the overall health processes, continual alignment of outcomes with business needs, And the continuous improvement is a long, well-established idea and set of practices that are used in manufacturing, in all kinds of areas, not just in IT. Continuous means that it is both proactive and reactive. So if something goes wrong, you see that there's a need to improve something. But even if things don't go wrong, you poll everything else that's involved and see, oh, could we do something better here? This is another way of looking at it, which is a much more. This is really a DevOps diagram, but it's basically the same thing as ITSM with some differences. The reason I'm showing you, I won't go through this because it's all the same. The reason I'm showing you this is because it is the engine of DevOps. It is the engine of agile computing. It's really the engine of modern computing. It's managing everything that's needed as it's running, and also as in DevOps as it's being developed. So I want to now go to give you an example of something that might look a bit like your team's project, the technology, and look at the IT lifecycle of that. And then I'll finish with some examples of looking at crashes from a whole of lifecycle view and also from inside an organization. So this is from you will, of course, know this by heart and could tell it to me with your eyes shut. Your team is part of the IT department within a large company. You've been asked to investigate the value, a really important word, and that is why I'm telling you about why you'll hear me mentioning the word business value so often, and showing you where it happens in the stages of the IT lifecycle. And in a minute, I'll show you where it happens in the structure of an organization. And you need, etc. You need to consider the nature of the technology, supporting the company, providing value, changing processes, and any risks that might exist. I pointed out to my tutorial groups today that this is an important word, change, company's processes. So looks like you're going to be involved in evaluating some change management processes as part of your implementing your new technology. So here we are in Colesworth. Huge, alarming for some of us, hard to navigate for some of us. Let's take a look before we talk about what your technology might look like. Let's take a look at Colesworth's structure. Let me say in the beginning, this is a fairly traditional organization, a large one, and not all organizations look like this, but many do, and many, even large organizations like this, contain within them other organizations, usually called X organizations, which operate like startups, which operate with a very short cycle of innovation and delivery. So this Colesworth includes that kind of organization as well. Whatever kind of organization it is, it has to have these kinds of processes. They don't look strictly like this, but it needs to have people who are decision makers, who are concerned with setting the direction for the organization, concerned with what value is wanted and how that might be achieved, and has to balance costs and risks, and also meet requirements. meet regulatory requirements, external regulatory requirements, and both external and internal ethical requirements. So when you come to talk about ethics, that will also have some relationship to these people up the top. Then these are the way often the different functions are. This is just fairly typical where the different functions are divided up within the organisation. So they're divided up at the board level, and groups of people from the board look after each of these. Underneath the board, you have a chief executive officer who is responsible to the board. The board makes decisions about things that should be done. There are rules and regulations, audit, risk management and compliance and governance that constrain how things should be done. The chief executive officer is responsible for making sure that the various departments do what has been decided up there. So we're only interested in the IT department, Colesworth IT. It has IT specialists. There's your group of 4. It has an IT stack, or you might want to call it IT infrastructure, that basically follows the technology stack layer of applications at the top, middleware, databases, operating systems, and hardware. Any of these items in this IT stack could be in-house, or they could be externally contracted. They could be outsourced. So your app, well, the app that I'm going to use as an example in this, it might run on some metal inside Colesworth, it might run on some metal outside Colesworth, whatever it might run on, software as a service, whatever. That's not actually our main concern at the moment. So, where are you in all of this? Here you are down here, and you've had this terrific idea that Colesworth should be developing an app which will, let me just go to the next. That's okay. Which will help customers find things in the store using a Bluetooth tracking technology. Now, as part of your working on this, you've got to get permission to do it. You've got to persuade the board of directors. Well, first you'll be persuading the CIO, and then she'll be persuading the chief executive officer, and then she'll be persuading the board of directors, probably through the technology committee of the board, of the value that this will bring to Colesworth. And the value could be something like, although customers, I mean, there's a certain advantage for Colesworth of not having tracking devices for customers to find things. And that is that people like me end up wandering about the store forever, buying things I don't want, not finding the thing I wanted, going home and having to have a cup of tea and a lie down. But there are advantages. If I have a tracking device, I can get what I want quickly and easily. And I'll see other things on the way anyway. I won't be so frustrated about going to the supermarket, and I'll come more often. Instead of using my local grocery store, I'll come to the supermarket. So there are all kinds of ways you can justify the benefits of it against the costs. So there you go. You've written your proposal. It's gone up here, and it has been approved. And it comes back down again, and you get to work on it. And it gets installed. I know that's not part of your project, but let's just imagine for a minute it is. It gets installed here, and then you will you won't be doing anything because you're developers, but unless you're working in Agile, and then you may still be responsible for it. But then while it's operating, pardon me, it'll be going through these stages. Before it's operating, operational, the strategy stage will be happening up here with the board of directors and the proposal. Design and build will be done with business owners and the IT specialists. Transition into the live environment will be done down here by IT specialists. And this is the IT environment. And then it's being operated. And finally, continuous improvement projects will be running to make it all run better. And that, I know that's not part of the project, but I just wanted to give you the example within something that might look a bit like your project. So here you are, standing in one of the aisles in Colesworth, wondering where the Vegemite is. Now, some of you may not know what Vegemite is, but Chowdhury, do you know what Vegemite is?
I know what Vegemite is.
You know what Vegemite is? Can you explain it to the group?
Vegemite is like Nutella, but bitter.
Okay, there you go. And in order to be, I think of all of you as Australians. Maybe some of you are just a temporary Australians, but you're all Australians while you're here. Vegemite is essential. You need to know what it is, and you need to have tried it at least once.
Yep.
It'll be in the exam. Anyway, so there you are, looking for the Vegemite, but you've got your Colesworth location tracker, and you just say, Vegemite, please, and it takes you, whooshes you. I wish I had animated that, but that would have taken me 2 days. Whooshes you to the Vegemite, and I still wouldn't have got it right. So, enough of the Vegemite. There is a little bit more detail about in following the same set of stages. I won't go through that, but you might find that useful for your projects. One of the this was actually at one stage. This is taken directly from either Coles or Woolworths, I forget which, a couple of years ago, for a case study that I did with another course. They had decided that a strategic focus for financial year would be to grow market share, which is a way of creating business value, by making life easier for the customer. So that's something that is a very, very common strategy for an organisation. That just tells you how they went about doing it, and the rest just covers what we've already spoken about. So I want to finish up. Are there any? There's no questions from that? No. Okay. You liked the dog better than the supermarket, huh? Mm-hmm. All right. I can cope. Looking at some project failures through a life cycle lens. Okay. And I'm not going to go into great detail about this, but what this example shows is the many places where things can go wrong, and how when we're doing a root cause analysis to find why something happened, why did it go wrong? Where do we fix it? There are often many places where it needs to be fixed, not just one. Root cause analysis sounds as though we might always be just looking for one cause of problems, disasters, or whatever, but it's not always so. So here was a bank in the United Kingdom, a lot of branches, 536, a lot of customers, a lot of money in it. In 2013, the bank was bought by another bank, a Spanish bank called Sabadell. So TSB is bank, stands for the Scottish Bank. You don't need to remember that. TSB had originally outsourced all its IT, running all its IT, to another bank called Lloyds Bank, which had a data centre. But because of certain EU regulations, it had to migrate its IT systems from that to its new owner's in-house platform called Service. So it's just a migration project. You can plan that and be precise about it, and you can do it. Big, but you can do it. It was very ambitious, and it took quite a long time to do. Eventually, the migration was carried out in 2018. Just to help you understand how big and complicated it is, that is just a diagram of the banking functions in a bank. I don't think it was all banking functions. I think it was just lending application processes or something like that. So what happened? Cybers tested the migration on only one of its 2 data centers, and hold that in your head. That could be a root cause. After the migration went live, 2 million people couldn't get into their accounts. Some people could see the accounts of other people. Mobile customers couldn't get into their accounts. This went on for a 3rd week and even a 4th week. Some customers were still unable to access their accounts. And IBM were called in to just take over everything and sort out the disaster. And there's the place, a link which tells you about it. So let's just travel down, pretend we're right in the center of TBS when this happens. So you remember I talked about during operation. So this migration had been moved into the live environment. The modified software had been moved into the live environment. And people are sitting around at their desks in the operations area, and an incident comes in. Somebody can't access their account. So the person on the service desk tries to fix it, and then it happens again. And then it happens again, and again, and again, and again, many thousands of times. So it's quickly, when somebody can't access an account, that's a fairly low level incident, which can normally be resolved at the service desk, and service can be restored, the help desk, if you like. Once you get the kind of situation of TSB, then it's what's called a SEV1, a severity 1 problem. And everybody in IT gets together. A bridge, a virtual meeting, is called initially of the technical staff from the hardware and software providers. And that in a situation like this, in a bank and in a bank migration to another data center, that would be a lot of different companies. And those meetings are extraordinary meetings because technical people, it needs to be technical people in the meeting because you're trying to find out what went wrong. So managerial people, business people are not really any use there and are generally not allowed to be in there. The technical people, though, have to keep in mind that it's their businesses, all the outsourced businesses on which this stuff is running, that are at stake. So they can't just say, it wasn't the network. People can't just say, no, it wasn't us. Definitely wasn't us. The data center people can't say it definitely wasn't us. Everyone has to contribute to solving the problem, not just because they have to be nice, not just because they have to play nice with their friends, but because there are huge penalties involved if it turns out they are the culprit. So I've been involved in these meetings, and they're just fascinating the way people have to negotiate with each other. And technical people who can't negotiate are sometimes just cut off, taken out of the meeting. Anyway, that's one aspect from the inside. But as the extent of the disaster becomes clear, execs from all areas in both organisations, according to the meeting, right up to the board level. And that might also involve execs not just from TSB and the Spanish bank that bought it, but it could be from those many other suppliers who are involved with it. Root cause analysis identifies the proximate cause that should be is the new data, untested data area. Remember, there were 2 data centers and one hadn't been tested. And recovery, if it's begin, they're initially unsuccessful. Eventually a new project. Eventually it's all sorted out. But the root cause analysis that TSB claimed, okay, that's the client, was that it was a technical issue in the data centers and inadequate testing by service. But as further investigations were done, it turned out that a lot of the fault lay with TSB at the board level. The board and the level of senior management, that they hadn't done their due diligence in all kinds of ways. That's just the total cost of it was phenomenal. The damage, of course, there's more references to it. But what I want to do is just go back for a sec to, okay, the life cycle stages, and say that the problems were, okay, some of these problems were at the transition level. But before you release into the live environment, you test and validate, and test and validate, and test and validate. But if there are things up here which haven't been done properly, no amount of testing and validating will do it. Now, finally, to finish, I just want to say that what was interesting to me about this case, and some of the lawyers pointed it out, was that the person from the Spanish bank who had used to run the data centers for the Spanish bank, remember the Spanish bank bought the Scottish bank, and they moved from the Spanish bank to the TSB and ran the migration project. So this person, in effect, had a foot in both camps. Because they were familiar with the data center of the Spanish bank and had run it, this person really didn't do all of the things that they should have done. And that involves questions of ethics, governance, audit, and so forth. So it's a big picture. The picture is not just here. So really that's all I want to say to you tonight. David, you probably want to say something to finish up?
Sorry, I was just unmuting. Yes, there are a couple of quick admin things that I might do. Thank you, Andrea. That was fascinating. I suspect there's probably questions, but what I might suggest is that if people do have questions, to post them on Ed, and if I can answer them, I will. If I can't, which is probably more likely, I'll pass them to Andrea or...
Sure. I'll look for them, yeah.
Do you want to stop sharing your screen and I'll switch back to sharing mine so I can run through a couple of very quick admin things? Thank you. Share screen. Okay, let me go back to there. So just before we finally wrap up this evening, a couple of quick admin things. The first one is hopefully you will have seen the post I put up on Ed. There are a set of the readings later in the semester, fortunately not yet, but I think from about week 7 onwards, I think, which refer to Gartner articles. And for some unknown reason, the universities changed the access to Gartner recently, so it was only staff only, not students, which means if you try to access those articles, you probably won't be able to. I'm trying to get that sorted out. If it's not sorted out within, by the time it becomes relevant for you to be looking at those articles, we'll find alternative ones. But hopefully that won't be an issue. Project teams. By now, everyone should be in a team that ought to have been resolved. I think there's a few tweaks that were needed in REO 5. I'm not sure whether they got sorted out earlier this evening or not, but if they aren't, we'll finalise those. But I think almost everything else has been sorted out by now. More significantly, there still appears to be a fair bit of confusion around the choice of topics. Probably less about the company. Most people seem to be kind of getting that sorted out, but more about the choice of technology within the company. So we were talking to the other tutors about that a little bit while Andrea was talking. Sorry, I was paying attention, Andrea, but we're also getting some feedback from the tutorials about this question. I think the biggest point of confusion has been that it is not about necessarily trying to find a technology that a company can market. It's not like you've got Apple trying to design a new product, which is kind of a core thing for it. It's about a company finding a technology that is useful as an enabler for them, something that will help them in their business, that will improve their ability to carry out their business, that adds value to the way they run. So I've got some examples there. We've been talking about supermarkets using Bluetooth localization. A supermarket won't get involved in Bluetooth because it's trying to become a company that designs, develops, or sells Bluetooth devices. They're using it as a tool to help them run their core business in a more effective way. In this case, to be able to track customers or support customers in finding products, etc. So they're using it for that, as a way of improving their business. You could get a university department who says, oh, hang on, there's these interesting smart tutoring software. We're going to use that to improve our teaching so that this move to having to do more things online can work more effectively. Or you might get a restaurant chain. You might have a chain of restaurants, that gradually over time have built up 10 restaurants around a couple of different cities, and they've kind of gradually grown. They've kind of become known as a small chain, or even a big chain like McDonald's, except that they're much more likely to already have an inventory management system. So you've got a small chain, started off as one restaurant, then they've got another one, then a few more. Now there's 10 of them, and they've suddenly sort of said, oh, hang on, we're kind of buying in stock ingredients for our restaurant chain, but we're not managing it very well. It'd be good to kind of be able to track it, allow us to buy in bulk so we can distribute it across our different restaurants, etc. So they might put in place an inventory management system, and there's lots of those around. Stock IQ is one, but there's lots of other examples of inventory management systems that let you track material that you have in stock. Lots of big stores have, big hardware stores have inventory management system. And often if you go, I know, my local hardware store, if I kind of go online, I can see whether something's in stock or not. And that's because they've got an inventory management system. And it's also tied into their sales system, so that when something gets sold, it knows that it's, that the amount of stock they'll have on their shelf is going to be less. And then you can use that to kind of control your ordering. So a restaurant chain says, oh, maybe that would be a handy thing for us to use. Or you might have a real estate company that says, we're going to use some customer relationship management applications to ensure that we follow up with potential sellers much more effectively. Or, a real estate agent that is managing the sales of houses. They have, the house next door to me is on the market at the moment, and on Saturday I was out the front of my house mowing the lawn, and suddenly all these people started kind of parking in my street and wandering into the house next door because they're looking at, it was an open day and they were looking at it to buy it. And so you get it might be a small real estate company, but they say, oh, hang on, we need to, rather than just when people come and look at an open house, writing their name down so that we can phone them up later on, we'll develop some software that lets us track them and automate messages to them, and things like that. Or a trucking company might say, oh, we our job is to cart things from city to city. And so we have trucks driving all over the place, and we've got software there that kind of tracks fuel use and, you know, GPS receivers and things. But we don't do much with that data. And so maybe we could use some data mining software to kind of analyze where the trucks are going and what routes they're following, and when they fill up and when they don't. And using that, we might be able to manage their fuel use and therefore save a lot of money on fuel. So in each of those cases, the technology is an enabling piece of technology, often something that's already existing. In fact, in all these cases, you know, the smart tutoring or the inventory management or the CRM or data mining software are already existing commercial packages. So I think maybe the thing that confused people was the reference to new technology. It didn't necessarily mean something that had to be cutting edge or even currently being developed. It's new to this company. So when we talked about a new technology, I meant a new thing for them, something that this company hadn't used before, but thought that maybe it would be useful for them. So hopefully that gives you a little bit better idea. Work with your, you can work with your tutor to finalise that if you haven't yet, and a reminder that it needs to be confirmed by the end of this week with your tutor, so that you can then actually start working on the project seriously, because you'll have a confirmed topic. They're the only things that I wanted to follow up with today. I'm already 1 minute past the normal end of the class. Normally I would make sure I finished well on time so that people will get to other classes, but I suspect there isn't going to be any other classes at 9 o'clock at night, so hopefully you don't mind me going a little bit over. Other than that, if you've got questions, feel free to post them on Ed. I'll go back and have a look at the chat. I won't try and answer anything in the chat now, but I'll have a look and see if there was anything there that I can respond to on Ed as well. Other than that, thank you, and thanks again to Andrea. She made took my rambles in the first half and turned it into something much more concrete and much more understandable, hopefully. I am incredibly jealous of her adorable, well, it's no longer a puppy.
Well, you've met her.
Yes, exactly. Pippi is an absolute delight. So thank you, Andrea, and we'll see everyone next week. So good night.
Bye. The slides are on Canvas. Oh, too late.